You know the feeling. We've all been there. You're staring at your phone, watching that little car icon just crawl across the map, and you are totally fixated on that estimated time of arrival. So today, we're going to dig into the how of it all. We're asking, what really goes into that number? Because I promise you, it's a whole lot more than just a simple guess.
Right? How do they actually know if your pizza's going to be there in 25 minutes or 35? Well, the answer is this amazing mix of old-school logistics, a little bit of human psychology, and some seriously advanced AI. So let's peel back the layers on this thing.
And the stakes here are just incredibly high. I mean, we're talking about a massive scale. Just look at DoorDash, one company, handling over 2 billion orders a year. And get this, Uber says that reducing the error on that little timer by even a few percentage points can unlock tens of millions of dollars. This isn't just about making you happy, it is a constant, high-stakes guessing game with real money on the line.
So, here's our game plan. We're going to go on a little journey to understand this billion-dollar guess. We'll start with the basics, the map problem. Then we're diving into the beautiful, unpredictable chaos of a restaurant kitchen. After that, we'll meet the AI models that try to tame it all, see how they learn to actually embrace uncertainty, and finally, find out exactly why every single minute matters so much.
Okay, first up, the billion-dollar guess. And here's the key thing you've got to understand. We have to stop seeing the ETA as just a timer. It's not. It's the output of a supercritical algorithm that influences everything, from which driver gets your order, to how happy you are as a customer, and yeah, even the final price you end up paying.
So to figure out how these companies predict the future, we first need to look at how they used to do it. It all started with a simple map. But the real story, the interesting part, is about moving beyond just finding the best route.
So in the beginning, predicting your ETA was a job for something called a routing engine. Just think of it like Google Maps on steroids. It looks at all the roads as this giant digital web, it factors in real-time traffic, and it uses these fancy algorithms to find what is, mathematically, the best path from the restaurant to your door. It's a great start, but, and this is a big but, it is fundamentally incomplete. Because a map, even a perfect one, can't see the whole picture. The team at Uber points out this huge variable, the human element. Your driver isn't a robot, right? They might take a different route they like, or they might make a mistake. And crucially, a delivery trip is totally different from a rideshare trip. You've got to find parking, maybe navigate a huge, confusing apartment complex. A simple map just can't deal with all that real-world messiness.
And you know what? That real-world messiness starts way before the driver even picks up your food. This brings us to the first massive hurdle that has nothing to do with roads or traffic, the kitchen chaos problem. Before a delivery can even begin, the food has to actually be ready to go. And this quote from the team at Zomato just illustrates the issue perfectly. Think about it. An ice cream sundae from way across town is faster than a complex dish like biryani from a place that's practically next door. Why? It's all about food preparation time, or FPT. It depends on the dish, how slammed the restaurant is, how efficient they are, you get the idea.
So here's the crucial statistical point. Food prep time isn't a nice, neat bell curve. It has what's called a right-skewed distribution. Okay, what does that actually mean? In simple terms, most orders get done pretty fast. But a small number of them, the really complex dishes, or when there's a surprise dinner rush, those can take a very, very long time. It's those outliers, this long tail on the graph, that make just predicting an average time so incredibly difficult. This is where the simple algorithms just throw their hands up in the air. This is where you need a much bigger tool. So, enter the AI forecasters. This is where machine learning comes in to actually learn from the messy, chaotic reality of billions of past deliveries.
Now, one of the key tools the AI uses is something called embeddings. The easiest way to think of an embedding is like a rich numerical personality profile. The AI creates these little profiles for absolutely everything. Every restaurant, every type of food, every hour of the day. And this lets the model learn on its own that two pizza places are just inherently more similar to each other than they are to a sushi bar, without a human ever having to tell it that. It's wild.
And the benefits of this, as DoorDash explains, are just huge. The AI can suddenly capture these incredibly complex patterns. It's way better at handling a brand new restaurant or a new menu item, and it can even reuse this knowledge for other things, like figuring out which driver is the absolute best for that specific job. It's just a much more sophisticated way of understanding the world.
And they don't just rely on one model. No way. DoorDash uses what they call a mixture of experts. Imagine a team of specialists. One expert is like a historian, looking at how busy the network's been for the past hour.
Another one is a strategist, looking at how specific things interact, like this restaurant during the Friday dinner rush. Then there's a manager, the gating mechanism, who listens to all these expert opinions and combines them to make one single super intelligent prediction.
But here's where the thinking gets truly next level. The most advanced systems out there understand that the future is, well, fundamentally uncertain. So instead of fighting that, they embrace it. It's not about predicting just one single number anymore.
We see this one confident number on our screen, 25 minutes. It feels precise, it feels certain.
But what if that single number is actually hiding a more complex and, frankly, a more honest truth? The reality is, the AI isn't 100% sure it's going to be exactly 25 minutes.
And this brings us to the huge difference between a simple point estimate and a true probabilistic forecast. Instead of just predicting 25 minutes, the model predicts an entire distribution of possibilities. Maybe there's a 70% chance it arrives between 22 and 28 minutes, but a 5% chance it takes over 40 minutes. You see? It fundamentally changes the question from when will it arrive to what are the chances it will arrive by a certain time. This is so much more powerful, because now the system doesn't just give you a guess, it tells you how confident it is in that guess.
Okay, so after all of this complex math, all this incredible AI, what's the actual payoff? This is where we see why every single one of those minutes really truly matters.
Well, the results are pretty staggering. After putting their deep learning models into place, DoorDash reported a 20% improvement in accuracy. And Cloud Kitchens, which gets unique data from inside the kitchens, saw a massive 42% jump over the old manual estimates. These are not small tweaks. These are total game changers.
And this quote from Uber really just drives the whole point home. What does this precision actually mean in the real world? It means drivers are dispatched more efficiently, so they complete more trips and they earn more money. It means we, the customers, are happier because our food arrives when we expect it to. It is a win-win-win that is worth an absolutely immense amount of money at this scale.
So the next time you place an order and it arrives exactly when the app said it would, just take a second to appreciate that invisible dance of data that made it happen. From routing engines and kitchen chaos, all the way to expert AI models and probabilistic forecasts, that simple number on your screen is the result of a truly mind-boggling amount of unseen complexity.